In the next few slides, we show how we conduct hypothesis tests on a population proportion. We define a proportion as the fraction or percentage that indicates the part of the population or sample having a particular trait of interest. The sample proportion is denoted by P and is found by dividing X by N. We show on this slide the formula for computing the z-statistic for testing a population proportion. In this formula, pi is the hypothesized proportion and n is the sample size. In conducting tests involving a population proportion, we can also apply the standard normal distribution or the z-distribution. We recall the assumptions in testing a population proportion using the z-distribution. These include a random sample is chosen from the population, the binomial assumptions discussed in Chapter 6 are met, and both the product of n times pi and n times 1 minus pi are at least 5. For the binomial assumptions, the following conditions must be met. 1, the sample data collected are the result of counts. 2, the outcome of an experiment is classified into one of two mutually exclusive categories, a success or a failure. 3, the probability of a success is the same for each trial. And 4, the trials are independent. This slide shows the 3 ways of setting up the hypothesis for testing a population proportion. The decision rule uses the z-distribution as an approximation to the binomial distribution. We apply the z-distribution when the conditions for using the standard normal distribution as an approximation of the binomial distribution are met. These conditions were discussed in the previous slide as well as in Chapter 9 when we talked about confidence interval estimation for a population proportion. The conditions are that n times pi and n times 1 minus pi are both at least 5. The equation found within the box is the formula for computing the z-statistic. In this formula, P is the sample proportion, pi is the hypothesized proportion, and n is the sample size. In computing the test statistic for testing a single population proportion using the z-distribution, we need 3 values: the sample proportion, the hypothesized population proportion, and the sample size. Just like in the previous tests we've considered, we compare this computed statistic to a critical statistic. So let's take a look at this example. Suppose prior elections in a certain state indicated it is necessary for a candidate for governor to receive at least 80% of the vote in the northern section of the state to be elected. The incumbent governor is interested in assessing his chances of returning to office. A sample survey of 2,000 potential voters in the northern part of the state revealed that 1,550 planned to vote for the incumbent governor. Using the hypothesis testing procedure at 0.05 significance level, assess the governor's chances of re-election. The keywords in this problem that will direct the correct setup of hypotheses are at least 80%, which translates to pi greater than or equal to 0.80. This is the null hypothesis. We set up the alternate hypothesis as pi is less than 0.80. This calls for a left tail test. The rejection region is on the left tail of the distribution. Given a significance level of 0.05, using the standard normal table in Appendix B1, we obtain a critical z-value of negative 1.65. We obtain this critical value by locating an area equal to or closest to 0.4500 in the z-table. Why are we looking for 0.4500? Because the areas in the table are from a z-value of 0 to a given z-value. And since the tail is equal to 0.05, the area from z of 0 to the critical z must be 0.4500. We found that by subtracting 0.05 from 0.50. Note that the test is left-tailed, and as such, the critical value must take on a negative sign. That is, the critical value is located on the left tail of the z distribution. After obtaining the critical z-value of negative 1.65, which establishes the boundary between the reject and do not reject the null hypothesis regions, the next step then is to compute the z-statistic. We substitute the sample proportion of 0.775, the hypothesized proportion of 0.80, and the sample size of 2,000 into the formula, and we obtain a computed z-value of negative 2.80. We note that the computed z lies within the region of rejection. So we can conclude to reject the null hypothesis. The evidence shows that the governor will receive less than 80% of the votes in the northern section of the state. As such, the evidence at this point shows that the incumbent governor will not return to the governor's mansion for another 4 years.